Hello class. In this lesson we're going to learn how to write unknown angle proofs, and we're going to use auxiliary lines to help us solve them. So similar to the lesson we had with transversals, we had sometimes an angle we were looking for that wasn't necessarily on one of the parallel lines, and we drew an auxiliary line to help us figure out what it measured. Same idea here. So we want to figure out what z measures, and there's two common ways of drawing an auxiliary line to do this. So why don't you try drawing a few and see if you come up with the same ones that I have. So the first one looks like this. I extended the transversal, so I get this triangle down here. And also, it gives us something special with angle, the angle that measures x and the one that measures v down here. What do we know about those two angles? We know they're the same, right? Because we have parallel lines and corresponding angles. What about the angle that measures w degrees and the angle that measures y degrees? Well, we know w and y must be the same because those are vertical angles. And so those are the properties that we're going to apply in our proof. So like always, we end with what we want to prove. Now we got to think, how do we get there? Well, we want to get z involved somehow. So how is z related to these angles on the triangle? Well, z is an exterior angle, so it must be equal to the sum of those two remote interior angles. So we have z equals something, right? We want to get the x and the y involved here. So, well, we know that x and v are the same, like I said before, because those are corresponding angles. And w and y are the same, because like we said, they're vertical. And so now how do we get from these steps down here? Well, we want to replace the v with the x and the w with the y. So when we replace that, that's just called substitution. So that's one way to solve this proof. One other way to do it is when we draw it right here through z so that we have an auxiliary line parallel to the original two. So what do we know about v and x in this case? Those are corresponding angles. And what do we know about w and y? Well, those are also corresponding angles. So we know that those x is equal to v and w is equal to y. So let's end with what we want to show. And how do we get there? Well, we said that x equals v already, so let's start there. And we said that w equals y, so we have that step. Right, corresponding angles. Now, how do we get z involved here? What does z equal? Well, looking at the picture, by the way we cut it, z is just going to be v plus w. That's the angle addition postulate. Right, those angles are adjacent, so we can just add them together. And now we just use substitution, and we get what we were looking for. So two different ways of solving the same problem. Here's a similar example because we have parallel lines. You think about where you would want to draw an auxiliary line. So in this case, I'm going to extend one of the parallel lines for my auxiliary line. So I'm going to extend DE through BC, like that. Well, you should all have little segment symbols on top. Because we're not talking about measurements, we're talking about these segments. Okay. So, well, we know we want to show that angle ABC is equal to the measure of angle DEF. That's what we're going to end with. How do we get there? Well, drawing that auxiliary line gave us some corresponding angles. What is angle ABC congruent to? Yeah, that's going to be congruent to EZC because those are corresponding angles. You could also call it angle DZC. As long as you pick 1 point from each side and the same vertex, you'll be good. Okay, what else do we have? Well, we want to get ABC this angle in here. I want to get that congruent to this one. And we said that we know that these two are congruent. So if we know something about DE, I'm sorry, missing that part over there. If we know something about DEF, then we'll be able to solve this. So what do we know about DEF? Well, DEF is congruent to EZC, because those are also corresponding angles. And so now what can we do? This measure equals the second one, that second one equals the third one. So we can use the transitivity property, or you can just call it substitution. Transitivity is always an application of substitution, so you can always say substitution instead. Substitution property of equality, just make it clear what you're doing. And in this one, let's see, we want to show that angle AEC measures A degrees plus C degrees. So where can we draw an auxiliary line to help us out there? Well, in this case, we're going to put one through E parallel to A, B, and CD. As a segment A, B, and segment CD. Okay, how does that help us out? Well, let's see. Angle BAE is congruent to what other angle? Oh, make sure you put down what you end with first. So angle BAE is congruent to angle AEF. So that also measures A degrees. And how do we know that they're congruent? Because we have what angle pair? Alternate interior angles. Right? Alternate interior angles are equal in measure. And what can we say about these two angles over here? Well, we know they are also congruent because we have alternate interior angles as well. So let's call them angles DCE and angle FEC. So how do we know AEC is A degrees plus C degrees? Well, looking at the picture now, that's just angle addition. So let's zoom on the whole thing. There we go. All right, so in this lesson, we learned how to write unknown angle proofs, and we applied auxiliary lines to help us solve them. Thanks for watching this video.